A very warm welcome to everyone watching and listening. The topic we have chosen today to explain is complete instruction execution. We are first year students of VIT Pune, Division D of Group 5. These are our group members. I am Daksh Saknani and I'll be explaining what complete instruction execution is. So what is complete instruction execution? Complete instruction execution is a process that involves the full execution of an instruction in a computer program. This means that all necessary steps involved in executing an instruction are carried out before moving on to the next instruction. The benefits of the complete instruction execution include improved program efficiency, reduced errors, and better use of system resources. In this presentation, we will explore how complete instruction execution works with examples. There are three total types of programs, which are fetch, decode, and execute. The next, fetch, will be explained by Uday.
Now I will explain what is fetching process. The instruction fetch operation is initiated by loading the contents of the PC into MAR and sending a read request to memory. Firstly, the content of PC have to be brought to initial bus and then it is loaded to MAR. After issuing the read signal, CPU has to wait for some time to get the MFC signal. During that time, PC is incremented. At the same time, the carry in to the ALU is set to work and add operation is specified. The incremented value from register Z back to the PC. Step 2 is initiated immediately after issuing the memory read request without waiting for completing the memory function. Step 3 has been delayed until the MFC is received. Once MFC is received, the word fetch from the memory transferred to IR. Now next, decoding process will be explained by Mahesh.
So now we are looking for decoding process. The decoding process. There are various instructions and we can never be sure which instruction belongs to which execution unit. Decoding sort this out. A decoder is responsible for the taking in the instruction and decoding it to assign to the respective execution unit to complete the execution instruction cycle. The decoding process allows the CPU to determine what instruction is to be performed so that the CPU can tell how many operands it needs to fetch in order to perform the instruction. The control unit of CPU has to first decode the type of instruction. There are three types of instruction includes in which memory reference instruction, register reference instruction and input output instruction. So now the further information which is execution instruction is been explained by Gargi.
The third phase of complete instruction execution is execution phase. In this phase, the CPU performs operations specified by the instruction and stores result in memory or a register. This phase may involve multiple subphases depending on the complexity of operations being performed. The goal here is to ensure that the operation is performed correctly and efficiently. Here we'll be seeing the addition of two datas stored in the registers R1 and R2. The steps to perform addition are as follow. First we'll have to fetch the instruction followed by fetching the first operand, which is the content of memory location pointed to by R1. The third step involves the actual addition in ALU, the result of which will be stored into R2. This execution follows a control sequence which will be further explained by Smith.
Now let's see the control sequence for this operation. Here the parenthesis indicates that it is a pointer, which means that R1 contains some memory location. Here the data from that memory location will be added to data in R2 and the result will be stored in R2. Initially the address of the addition instruction is stored in program counter, and therefore PC out will give that address and it will be stored in MAR, that is memory address register. Then the memory will read the data. During this, another operation is performed, that is incrementing the program counter, and address of next instruction will be stored in the program counter. For this, we are selecting 4 in the multiplexer, which will come to A, and PC conduct will come to B, and add PC conduct with 4 and store the result in Z, so Z in. Now Z out will be followed by PC in. Now WFMC is waiting for memory function complete, which is a signal from memory which will be set when the read operation is completed. Here, after this, the instruction will be stored in MDR, that is data register, and which will then passed on to the instruction register, that is MDR out IR in. Now let's fetch the first operand from the memory. R1 is the first operand which points to some address and which contains certain data. So we should do R1 out, MAR in, and then read. So the data from R1 will be read in MAR, and we are waiting for the read operation to complete, and when the read operation is completed, it will come in the MDR register. That MDR data will be taken out and stored in Y register temporarily. In between, one operation will be happening as we need the second operand R2. So R2 out and data from this register is stored in Y, so Y in. So first operand is available in MDR and second operand is available in Y. So they both move to ALU for addition and the result is stored in Z, so Z in. Now the data will be taken out to the Z, so Z out. This result will be stored in R2, so R2 in, and the instruction is completed. Now let's move on to the conclusion, for which I would like to hand over to Snehal.
Let's summarize what we discussed above. In computer program, the complete instruction of the program is stored in main memory, and during execution it fetches the instruction from main memory one after another. The sequence of instruction fetch is controlled by the program counter. Complete instruction execution is a critical process for ensuring the correct and efficient execution of computer programs. By following the 4 phases outlined in this presentation, programmers can ensure that their programs are optimized for performance and accuracy. By understanding how complete instruction execution works, programmers can also identify and resolve potential issues with their code more easily. This makes it an essential skill for anyone working in the field of computer programming. Thanks for watching our video, and if you found it helpful, then like and comment below. Thank you.